In this section, I will look at DNS records. DNS records contain the data that will be returned to the client when the client requests information from the server about hosts or resources on the network. In this video, I will look at different DNS records. There are a lot of different types of DNS records, but I will look at only the most common. Next, I will look at dynamic DNS. Dynamic DNS allows clients to adjust their own DNS records as they change. This can be a real time saver. Lastly, I will perform a demonstration of how to create DNS records and how to use dynamic DNS. DNS is a key part of Active Directory, so it is beneficial to understand how DNS records work. Once you understand how DNS records work, you will have a better understanding of how Active Directory finds resources on the network, helping you to troubleshoot Active Directory problems on your network. With DNS, there are a number of different record types. This is by no means a complete list, but does cover the more common types. The first record is Start of Authority, or SOA. The SOA record indicates the DNS server with the best source of information for that zone. This should be the primary name server. Simply put, it is the DNS server which has the most authority to make changes in the domain or answer questions in regards to it. Contained in the SOA is the email address of the administrator of the domain. The SOA also contains configuration information for replication. This includes the domain's serial number. The domain serial number is a number that tells other DNS zones which version of the DNS zone that server contains. When changes are made to the zone, the serial number will increase. The next most common record is the A or Quad A record.
This record maps a name to an IP address.
The A record is used for IP version 4 addresses, while the Quad A record is used for IP version 6 addresses. For each computer or device on your network, you can create an A record or Quad A record for it. If you have dynamic updates on, the record will be created automatically for you. In some cases, you will want to map a service to a host name. For example, you may want to map the name Mail to your general application server called App1. You could create a new A record for the host. However, if the IP address of that host were to change, you would need to update two records. To help with administration, DNS allows you to create an alias record called a CNAME, which stands for Canonical Name. The CNAME record points to an A record or Quad A record. When you attempt to resolve a CNAME record, the corresponding A record or Quad A record is returned. With CNAMEs, you can also change the destination the CNAME is pointing to. For example, if you moved your mail server from App1 to App2, all you would need to do is change the CNAME to point to App2 rather than App1. Without the CNAME, you would need to change every client on your network to point to the new server. You can see that by using CNAMEs, you can save yourself a lot of reconfiguration headaches on your network when things change. Originally, DNS was designed only to resolve hostname to IP addresses. Since then, it has expanded to allow users to find resources and services on the network. To do this, DNS has service records or SRV records. A service record allows a client to locate services on the network using DNS. Service records are used by Active Directory to allow a client to locate a domain controller. This is why DNS is so important in a Windows environment. Lastly, you have the Mail Exchange or MX records. When you attempt to send an email, the email server will read the MX records for that domain. Each MX record has a priority. The lower priority MX records are tried first. If the email server cannot contact the server with the lowest MX priority, it will try the next one. To better understand how MX records work, consider this example. In this example, there is an email server in the USA and one in the UK for the same company. Both email servers for the UK and US are connected together by a high-speed link. A client attempts to send an email to the example.com domain. The first MX record for example.com is read. This has a priority of 5. If the mail server can be contacted in the U.S., the email will be sent straight to this server. If the server cannot be contacted or the server is down, the next MX record with the higher priority will be read. In this case, mail.example.com.uk with a priority of 10. If the first server cannot be contacted, all emails for example.com will be sent via the UK server. In other words, each server acts as a backup for the other servers. I have seen this set up in many different companies. Having backup email servers stops emails from being bounced back to the sender when there are long outages. The backup email servers do not have to be on other sides of the world. In some cases, the same company may have multiple email servers at the same site. Regardless of the case, remember, lower priority MX records will be tried first. Don't confuse priority with load balancing. If the server with the lowest priority is online, then all email for that domain will be sent to this server. The last record I will look at is the PTR record. There are other DNS record types. However, those I have looked at so far and the PTR records are the main types. PTR stands for Pointer Record and simply maps an IP address to a name. Windows can create the PTR records automatically, but in order for this to happen, you must have a reverse lookup zone created to store the PTR record. In a moment, I will show you how to create a reverse lookup zone. In the real world, I have worked on large networks that don't have a single reverse lookup zone created. For Active Directory to run, you don't require any reverse lookup zones. Reverse lookup zones are mainly used for troubleshooting tools such as traceroute and DNS lookup. Even though you can get away with not having any reverse lookup zones, when you are troubleshooting network problems, you may find an IP address in a log file. It is useful to be able to perform a reverse lookup and find out the host name for this IP address. In the old days, you had to update your DNS records manually. With Windows Server 2000 came the ability for clients to update their DNS records dynamically. This is controlled by the service DHCP client. If your client is not automatically updating its records in DNS, make sure this service is running correctly. If you want to force the client to update its settings, run the command ipconfig/registerdns. This will force the client to update its DNS records on the DNS server immediately. If you are trying to connect to a user's computer remotely and DNS cannot resolve their IP address, you can often fix the problem by getting the user to run this command. With dynamic updates, you can also configure it to use Secure Update. This stops a hacker from inserting their own records in your DNS server and redirecting your users to the hacker's server. In order to use Secure Updates, the client must be a Windows computer and be in the Windows domain. DHCP can register DNS records in your DNS server. If you have any non-Windows clients, this is a workaround for this client not being able to update their own DNS records. Let's have a closer look at DNS records on Windows Server 2008. To add records to your DNS server, run the DNS admin tool from Administrative Tools under the Start menu. I want to add some records to the test.local forward zone. As you can see, there are a number of records that have already been created in the test.local forward zone. These records have automatically been added using dynamic DNS or created when Active Directory was installed. In some cases, you may want to create an alias or CNAME for an existing record. To do this, right-click and select New Alias. In this case, I want to add an alias for Windows Update. This will point to the server WSUS. At present, WSUS is its own server. Later on, I may consolidate this server so that WSUS is on another server with other services. When this occurs, I don't want to have to reconfigure all my clients to point to the new server. By using an alias, when I move the WSUS server, I simply have to update the alias to point to the new server. Updating an alias is a lot easier then going around and reconfiguring all the clients. You can see now an alias has been created for Windows Update. This alias will point to the record WSUS. In a lot of cases, the Windows clients will automatically create a dynamic DNS record for you. In some cases, you will need to create a manual entry. For example, you may have a computer that does not automatically register itself in the DNS server. When this happens, you will need to create a manual entry in your DNS server. In this case, I will create an entry called app2. app2 is a Unix server that does not have support for dynamic DNS, so I must create a manual entry. To do this, right-click where you want to create the new record and select New Host. All I need to do is put in the computer name and the IP address. You will notice that the tick box Create Associated Pointer PTR Record is ticked by default. This will automatically create a reverse lookup entry in the reverse lookup zone if a reverse lookup zone is available. You'll notice that you now get a message letting you know that the DNS record was created. If I now open the reverse lookup zone, you will notice the PTR record. Another of the more common DNS records you may want to create is a Mail Exchange Record, or MX record. To do this, right-click and select New Mail Exchange. All I need to do is enter in the fully qualified domain name for the Mail Exchange record. The mail server priority indicates the priority this mail server will receive. The server with a lower priority value will be tried first. Servers with the same priority value will be used interchangeably. In this case, I will accept the default 10 and create the record. In some cases, you may need to create another type of DNS record not listed in the menu. To do this, select the option Other New Records. As you can see, there are a lot of DNS records you can create. One of the more common records you may need to create is an SRV record, found at the bottom. Service records allow programs to find services on the network, for example, domain controllers. If I go back, you will notice that so far, most of the records are host A records. A refers to a name record that uses IP version 4. If you were to create a host record for IP version 6, this would appear as quadruple A. I will go through manually creating an IP version 6 host. However, before I do that, I'm going to create a reverse lookup zone for IP version 6 addresses. To do this, right-click Reverse Lookup Zone and select New Zone. From the wizard, I'm going to select Primary Zone and store the zone in Active Directory. In this case, I will leave it on the default and allow the data to be replicated to all domain controllers. To create the IP version 6 zone, all I need to do is select the option IP version 6 Reverse Lookup Zone. Next, I need to enter in the network address for where I want this zone to save the IP addresses. I will leave it on the default, allow only secure dynamic updates, and move on. That's it. Press Finish, and the IP version 6 Reverse Lookup Zone is created. Now, if I right-click Test.Local/Lookup Zone and select New Host, I can create a new host. All I need to do now is enter the hostname and copy and paste the IP version 6 address in the IP address toolbox. Notice I can leave the tick box Create Associated Pointer PTR Record ticked as I have a reverse lookup zone created. The IP version 6 host record is now created. If I go back to the forward lookup zone, you will notice that the new quadruple A record has been created with the IP version 6 address. You will notice at the top of the screen there are a number of folders that start with an underscore. These contain some of the service records that the Active Directory uses to tell clients where resources on the network are located. For example, in the _UDP folder, there are the service records for the domain controllers for this domain. Windows will create these automatically for you, so you should not have to create them yourself. If you delete these records, your clients will not be able to locate any domain controllers and thus not be able to log on to Active Directory. If for some reason you did delete these records or they were damaged, go to the properties for the zone and make sure that dynamic updates are switched on. If it is set to none, the net login service will not be able to create the DNS records. Try switching the setting to either non-secure and secure or secure only and restarting the net login service. This should recreate the missing or damaged Active Directory service records. If I select the Aging button, I can switch on the option at the top, Scavenge Stale Resource Records. When you have this option on, DNS will automatically remove records from its database that it thinks are no longer required. The next option, No Refresh Interval, sets how long until the timestamp for the record can be updated. If you attempt to refresh the record before this time has expired, in this case 7 days, the DNS server will not update the timestamp. Once the time period has expired, the timestamp can be updated. The next option sets how long until a record can be scavenged or removed from the DNS database. What this means is that after the no refresh interval has expired, the DNS record can be refreshed for a period of another 7 days. If the record is not refreshed in this time, the record may be removed from the DNS database. In this example, it would take 14 days for a DNS record to be considered no longer required and removed from the database. A lot of the time, these settings correspond to the settings in your DHCP server, since DHCP can also update your DNS records. If I now run the DHCP snap-in, I can expand down to IP version 4 and select Properties. In Properties, if I select the DNS tab, I can see how DHCP will work with DNS. You can see the first option enables dynamic update according to the settings below. The next two settings only apply to clients that support dynamic updates. The first setting will only update the DNS records when the client asks the DHCP server to do so on its behalf. The next setting also dynamically updates DNS, A, and PTR records. When you select this setting, if the client supports dynamic updates, the DHCP server will always update the DNS records for them. The important thing to understand is that the client needs to support dynamic updates. When a lease expires, DHCP will tell the DNS server to remove the entry from its database. Without this option on, the DHCP server may allocate the IP address to a new client. When you attempt to resolve the old client's name, it no longer exists on the network. You will instead get connected to the new client. If you are using remote control software, this can be quite embarrassing when you connect up to the wrong client. With careful planning, you should be able to keep your DNS database up to date. On a large network with a lot of computers coming and going from the network, dynamic updates save you a lot of time and headaches. If you decide to use dynamic update, make sure you give some thought to keeping them secure from hackers. If your DNS server is behind a firewall, then you should not have any problems as long as the hackers cannot break into your network. If your DNS server is accessible from the internet, it is possible for a hacker to insert or even update DNS records and redirect your users to their servers. Lastly, have a good understanding of the common DNS record types. Without DNS, Active Directory cannot run. It is important to understand DNS as a lot of services rely on DNS to operate.